Okay, this problem is asking us to do a lot of things actually, having to do with a piecewise function. So what a piecewise function is a function that looks like two different types of functions all combined into one. So this is how it looks like in equation form, and what I like to do first before even going through any of these questions is I'm going to graph it first. So I'm going to start with this top one, because if x is less than 0, our graph is going to look like the graph of 4 plus 2x. So how would that look? I'm actually going to rewrite that. So just think of this as the equation y equals 2x plus 4. Hopefully you can see how I got that, because f of x is kind of like a y. I just reordered the 2x, I wrote it first, and the 4 second, because that's like the form y equals mx plus b. b is the y-intercept, 2 is the slope. So I'm going to start that in red here, starting with my y-intercept of 4. 1, 2, 3, 4. I could put my y-intercept of 4 right there. Now the slope is 2, so I can go up 2 and to the right 1, or I could go down 2 to the left 1, down 2 to the left 1, down 2 to the left 1. Either way, I come up with this straight line here. Let me connect it. Now I'm going to, let's see, I'll start up here I guess, because you'll see what I'm going to do in a second. But there's my straight line. Now that's just the graph of y equals 2x plus 4. I don't want this whole graph of y equals 2x plus 4, because I only want it to look like this when x is less than 0. So this is going to erase some of my other boxes here, but I don't want it to look like this red graph here when x is greater than 0, only when x is less than 0. So think about the x-axis here. When x is less than 0 starts at the y-axis on down to the left. So I'm actually going to erase this up here because I don't need any of that. I only want from when x is less than or equal to 0 to be showing up. Now in blue here, I'm just going to do it in different colors so you can see the difference. In blue I'm going to graph y equals x squared. And think about what would that graph look like. Well, that graph goes to the origin right here at 0, 0. When you square the number 1, you get 1. If you square 2, you get 4. 2, 3, 4. If you square 3, you get 9, so that'd be way up here somewhere. And it would look the same on the left side too. So if I was graphing my whole graph of y equals x squared, it would be connected all the way around. But I don't want this whole graph. I only want it to look like this graph if x is greater than or equal to 0. So I'm going to have to erase this whole left side down here. So I don't want it to look like this graph unless y is greater than or equal to 0. So there's a couple of things here. Since it says greater than or equal to 0 here, I want to make sure this is a closed circle. Since in red up here in this first part it just said x less than 0, I had to make sure that this one was going to be an open circle. So I don't want it to be equal to 0, because when x is equal to 0 it jumps down here and starts looking like this x squared graph. So this is actually my graph. It would all be in one I mean, this is a rough sketch, because this should look like a parabola, more like a straight line. It's kind of curving upwards here, but that would be my graph of my function. So now it says find the domain of the function. Domain is looking at the function from the left to the right. How far left does it go to how far right does it go? All the x values. Well, this would be from negative infinity to positive infinity, because we have all the x values are defined on this graph to be some y value. Locate any intercepts. Now that I have my graph, because I drew it, I can actually find the intercepts by looking at my graph. So I can see one of my intercepts is over here at negative 2, 0. The other intercept is at 0, 0. If you didn't have your graph yet, you could figure that out by putting a 0 in the x spot to find the y-intercept and putting a 0 in the y spot to find the x-intercept. And you could do it for each equation here. Then you graph the function. I already did that. I'm kind of speeding up here because I'm running out of time on my video. But based on the graph, find the range. Now the range is looking at the graph up and down ways, so this is actually also negative infinity to positive infinity, because the graph goes as low as negative infinity and as high as positive infinity, even though it jumps right around here. Excuse me, I had a sneeze. Even though it jumps, it still is going from negative infinity to positive infinity. Is f continuous on its domain? To be continuous means you could draw it without lifting your pencil on the domain, and on its domain it is discontinuous, so we would say no here.